Hello and welcome to this video. This is a Unit 8 volume video. Okay, so we have these curves. We have 2 square root x, and the y-axis. Let me make sure I'm not screwing this up. There we go. Okay, we have 2 square root x. We have the y-axis, and we have y equals 4. So these define the region. Okay, so 2 square root x basically is going to look like this. Okay, the y-axis, of course, is this guy. Y equals 4. 1, 2, 3, 4. Gotta make sure it intersects. Just like that. Awesome. Okay, now the region we're talking about, remember that's important. We got to make sure we know what the region is. Here is the region of integration. Okay. Boom, 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 boom. This is the region of integration. And now this is a volume problem, not an area problem. So what we're going to do is we're going to take this region and we're going to create a solid by rotating this thing around the y-axis. So think about this figure, going into the screen like a circle. It's like circulating around the y-axis. So it's going to make this three-dimensional sort of circular thing. Okay. Where, and then when it's 180 degrees around, it will look, the two-dimensional view will kind of be like this. Okay, but this is really, again, it's really a three-dimensional. It's coming out of the screen, it's going into the screen, so on and so forth. Okay, so basically what's happening is, if I consider any one of these, just any value in the world, right? If I make this segment and then rotate this segment around, then this thing becomes a radius, okay? And, this little cross section here will actually produce a circle, okay, with radius this, okay? And this, let's be very clear, this distance is an x distance. Okay, it's an x distance. So that means that we need to integrate with respect to y. Now, why is that, right? It's because the x value, is changing from point to point. Okay? And so if we integrate all of these changes, it'll give us the exact volume of the 3D solid generated. Okay, but we got to make this thing in x first. So I'm gonna actually solve for x here. I'm gonna divide by 2. Y divided by 2 equals the square root of x. And then if I square both sides, I get that x equals y squared over 4. Okay, so awesome. All right, and again, this is basically my radius. Okay, now since we're integrating with respect to y, what is the minimum and maximum y value for this problem? Well, the minimum y value is down here, 0, and the maximum y value is going to be this bad boy right here, 4. Integral is 0 to 4. And now once again, this is a radius, and when I spin this around, it's going to produce a circle. Okay, and then if I add all those circles together, it's going to give me a volume. Okay, so in other words, an area has to go here. And, since it's a circle, the area of a circle is pi r squared. Okay, but then the radius is here. Okay. So yeah. So anyway, we're going to have integral 0 to 4, and then it's going to be pi, and then it's going to be this thing squared. Okay. So if I square y squared, I get y to the 4th. If I square 4, I get 16. Awesome. Okay. And now that is going to be dy. All right. Awesome. Okay, so now, well, the pi over 16 is a constant. It can come out in front. Integral 0 to 4, y to the 4th dy. Pi over 16, and then power rule, right? Y to the 5th over 5, evaluated from 0 to 4. Pi over 16. And then I'm going to have 4 to the power 5 minus 0 to the power 5. All of that divided by 5. And we're going to have pi over 16, which is like 4 to the 2, times 4 to the 5 over 5. So that's going to be pi, and then remember this is 4 to the 2. 5 minus 2 is 3, so we get pi times 4 to the power 3 over 5. Okay, and so that's going to wind up giving us 64 pi over 5 for that volume right there. And let me consult with the textbook. Yes, that is correct. Awesome. Okay. Yeah, so that's just a disk method example where we have to integrate with respect to y. Okay. So, yeah. Hope that makes sense.